What is JVM? JVM, it means Java Virtual Machine. See, in JVM, there is available memory. Then first block here start with the class loader. That you can simply say JVM language classes. Then class loader, the input is dot class file. It means first we are going to create the source code. It means .java file, and by using Java, it means Java compiler, it will convert .java into .class file. Then for class loader, the input is .class file. Class loader, it will take care of loading those .class file, and accordingly once it loaded, then it will split into those memories. Then JVM have memory like method area, heap, JVM language stack, PC registers, native method stack. In method area, which type of information goes to store? Like class level information. The class level information, it means whatever we have method available there, static variable, instance variable, such a type of data, it will goes to inside method area. And heap, it means whenever you are creating the object by using new keyword, then this object goes inside heap area. JVM language stack, it means whatever you are adding within local like method, inside method, then this will be like local variable. You can simply consider such type of information, such type of data, it will go add with the JVM language stack. And PC registers, it means current execution instruction. I'm sorry, I'm giving the best example here. Like suppose we have available result equal to n1 plus n2. This is on fly instructions we are giving, right? Then such type of data, it goes to PC registers. You can simply say current execution instruction, it will goes PC registers. PC registers, it means whatever current running instructions, right? Current execution instruction, such type of data goes inside PC registers. Best example I'm giving here, result equal to n1 plus n2. You are trying to do like addition of two number, right? Then on fly, this data goes inside PC register. Native method stack, it means whatever legacy methods, those will comes inside native method stack. Now coming to next we have available here execution engine. Execution engine, it means you can simply consider like Java, it's a Java interpreter. It will help us to run this bytecode, and finally we are getting the machine readable format as a output. Then execution engine itself available, there is JIT compiler, just in time compiler. It will help us to improve the efficiency of our Java application. Then coming to next is native method interface, native method libraries. Whenever native method comes, you can simply say those are the legacy methods. Same for native method library as well. Those are the legacy method libraries. Like this is the JVM architecture. Now I will deep dive into some theory part here actually. See, JVM, it means Java virtual machine. There is available memory like method area, all the class level information like class name, immediate parent, class name, method, and variable like static variable as well. Those stored within, you can simply say method area. And heap area, it means whenever you are creating the object is stored in the heap area. Then static area, for every thread, JVM creates one runtime stack which is stored here actually. And you can simply consider all the local variables of that particular method are stored in the static area only. Local variable, it means you are going to add inside method, yeah, block. Such a type of data, it will goes inside static area. Now coming to PC registers, store the address of current execution instruction of a thread. Obviously, each thread has separate PC registers. Coming to next is native method stack. For every thread, separate native stack is created, and it stores native method information also. Then coming to next is we have available execution engine itself available JIT compiler. That's called just-in-time compiler. It used to increase the efficiency of interpreter. It compiles the entire bytecode and changes it to the native code. So whenever interpreter see repeated method calls, then JIT provides direct native code for that part. So reinterpretation is not required. Thus efficiency is improved. It means in short, you can simply say JIT, it means just-in-time compiler. It will help us to improve the efficiency of our Java application. Now coming to next is how the Java program compilation happens internally. Then initially we are creating .java file, and by using Java C, Java compiler, it will convert .java into .class file. Dot class file, it means you can simply say this is the bytecode and we are not able to read this. Then Java itself, Java have interpreter. Then Java itself, Java interpreter. Then Java interpreter read this dot class file, it means bytecode, and finally it will give us the machine readable format as a output. At the end, you are able to see the output there, right? Yeah. It means the compiler compiles the Java file like .java into a .class file. Then .class file is the input to the JVM, which loads and executes the class file. And finally, here we have available execution engine, like it will like itself available Java interpreter, right? It will read this bytecode and finally it will give us the output in machine readable format. And I hope you got like somehow the high level architecture of JVM. Then coming to next is today's concept. We'll start with the typecasting. JVM, there is no code. This is just like architecture. This is entire theory part we have covered here. Then typecasting in Java. Typecasting, it means convert one type into another type. Convert one type into another type. Type, it means you can simply say data types actually. There is available primitive and non-primitive data types in Java. Then typecasting has two types available there. The first one is upcasting and the second one is downcasting. Upcasting, it means you can simply say lower to higher, lower to higher, and downcasting, it means higher to lower. Best example of lower to higher, it means into double, and downcasting best example double to int. Then see, typecasting, it means convert one type into another type. There are two types of typecasting in Java. The first one is upcasting and the second one is downcasting. Upcasting, it means lower to higher. The best example into double, float to double, byte to, you can say short. Again, you can simply say into long as well, into float as well. And downcasting, it means higher to lower. The best example is double to int, double to long, double to wide, double to short as well, right? Yeah, float to int as well. Then downcasting, it's simply like higher to lower. Now we'll come up with the practical approach here. How like we are going to add the upcasting and downcasting in our practical example. For that perspective, I am just coming to file and creating new Java application. File, new dynamic project. The application name I'm giving here typecasting concept. See, our application is created successfully. Now coming inside src main Java, we are creating new Java package. The package name is com dot, we are giving here VDI dot core. Com, it means OS level, core level package. VDI, it means our company name. Core, it means we are learning the core Java here. And package, all letters must be lowercase. Now simply right click on package, new Java class, and the Java class name I'm giving here. This is upcasting example. Upcasting, it means lower to higher. Then here I am writing the main method. This is public static void string arguments. Then lower, it means integer. I am just passing here emp salary equal to, we are giving here 97,000. Now we are using double. This will be, you can simply say employee salary equal to emp salary. Now we are trying to print here employee salary. What will be the output of this program? Anyone have any idea about that? This is called, you can simply say upcasting. Upcasting, it means lower to higher. Integer is lower, double is higher. Any idea about that? What will be the output of this program? Yes, this is our output. And that's called, you can simply say upcasting. Upcasting, it means lower to higher. Int is lower, double is higher. We are converting lower to higher. That's called upcasting. And this is the best example for upcasting. Now we are creating the one more example here for downcasting. Downcasting example. I'm simply adding here main method and giving here double. This will be, you can simply say prod have price. We are passing here like 78,000.96. Now I'm adding integer product have price equal to product price. Then trying to print here product price. But here it will give us the compilation problem, right? What is the problem of compilation? Now here we are doing downcasting. If you are doing the downcasting, there will be some compilation problems comes. It means appropriate type of value you need to convert into int. Now this is product price, it means this double, and we are trying to convert into int. Then you can simply mouse over there. It will give us the suggestion add cast to int. It means we have converted this double into int type. Fine, because we require the integer type of value there. And here double to int, it means this will be the downcasting. Now what will be the output of this program? Downcasting, it means higher to lower. Here double is higher and the int is lower. It will lose the pointing value, right? Because we have converted here double to int. That's called downcasting. Then see on screen, we are able to see only 78,000 because we lost here pointing value. How? Because we are converting double to int, and int don't have capacity to store the pointing value. That's why we convert here this double to int actually. Now coming to next example here, and this is for question for all. Typecast example. See, here is main method, and now I'm just passing here string, and string I'm giving emp code. Otherwise you can simply say emp code also fine. We are giving string type of value in double quotes. Now I'm giving here AA99. Now I'm using again integer employee code. Integer employee code equal to emp code. I'm trying to print here employee code. The question is very simple. What will be the output of this program? First, we need to handle here compile time problem, right? Then we are converting into integer. Then you can simply say integer dot parse int. You have options available, different approaches actually to convert one type into another type. Now, what will be the output of this program? Anyone have any idea about that? Program is only 3 lines of program available here, right? We declare the one variable like emp code. There is string type of value we have defined. Then we have converted the string type of value into int by using integer dot parse int. And here we are just trying to print the employee code. What will be the output? Try to participate actually from your side as well. Aditya saying 99. Learn the concept, right? Like integer stores only integer type of value. But here we are trying to add here alphabetic value as well. Then definitely Java, it will give us the exception. And here we got the runtime exception. The exception name is number format exception. See on screen. Which exception we got here? We got here number format exception. Why? Because integer don't have capability to store such like alphabetic value like AA. We are not able to store within integer. That's why simply remove this alphabetic value, and then you can go ahead. It will print the 99. See on screen. Perfect. Then if such a scenario comes like upcoming sessions, you are going to work on project, there also such a scenario comes actually like string type of value you need to convert into integer. Then end user we need to restrict, like you can simply pass the integer type of value there. If they are passing the numeric value, it will give us the exception. Fine. Then we have separate session available for exception handling in upcoming sessions. Now I hope like you got some basic clarity of how the typecast work internally. Then coming to next is boxing in Java. Boxing in Java. Boxing in Java. Anyone heard about boxing? Boxing, it means convert primitive type into wrapper class. Convert primitive type into wrapper class. That's called auto boxing in Java. The best example here, int is a primitive type into integer. Wrapper class, integer is a wrapper class here, and class first letter must be capital. One more example I want to suggest here, double to double. See, which is the primitive type? Double. And the wrapper class first letter must be capital, right? Then auto boxing, it means convert primitive type into a wrapper class. And there is one more concept available, unboxing. Unboxing in Java. Unboxing, it means convert wrapper class into primitive type. Convert wrapper class into primitive type. Then see the best example for unboxing. You can simply say unboxing, it means vice versa about auto boxing. Integer to int. One more example, you can say boolean to boolean. One more example, character to char. You can give number of example here, no worries. Fine. Yes. Then auto boxing, it means convert primitive type into wrapper class. The best example, int is a primitive type, we are converting into integer. Double is a primitive type and we are converting into double as a wrapper class, and class first letter always must be capital. Coming to unboxing, unboxing, it means convert wrapper class into primitive type. This is the wrapper class and this is the primitive type. Again same thing, here is the wrapper class, this is the primitive type. This is character is a wrapper class and the char is a primitive type. Convert wrapper class into primitive, that's called, you can simply say unboxing. We'll come up with the practical approach. Then I'm creating here new Java class. On the Java class name I'm giving here auto boxing example. This is very easy concept in Java, actually those are the basic concepts. Then now we are converting primitive type into wrapper class, that's called auto boxing. Integer, I am passing here emp id equal to 121. You can simply use here integer employee id equal to emp id. We are using printing statement and trying to print here employee id. Here you can simply say this is called auto boxing in Java. Auto boxing in Java. Auto boxing, it means convert this emp id is a primitive type. It means int. We are converting into wrapper class, it means integer. That's called auto boxing. Convert primitive type into wrapper class. That's called auto boxing. And here it will give us the output as well. Then for your practice, you can use different primitive type and try to convert into particular wrapper class. I'm just giving here one example, but you can use byte, short, int, float, long, double, char, boolean, whatever you want. Now coming to next is unboxing in Java. New Java class. I'm giving here unboxing example. See, here is main method. Now I'm adding here, this will be, you can simply say integer. Integer, we are passing here employee id equal to 121. But here we are just trying to remove this proper variable name I'm giving here. Now passing int employee, emp id, you can simply say equal to employee id. Trying to print it emp id, it will give us the output as 121. See on screen. Perfect. Then here, which is the wrapper class? Integer. Which is the primitive type? Int. We are converting wrapper class into primitive type. That's called, you can simply say unboxing. That's called unboxing. And finally, it will give us the output as well. See on screen. Perfect. One more example, we are giving here double. You can simply say this will be emp have salary. Emp have salary. I'm just adding here 97,000.22. Then here we are using this is primitive type, and you can simply say this will be employee salary. See, finally we are going to print here salary. See, this double, this is class. See, it means class, and double class, this is our wrapper class actually. See, here given some theory as well, right? Yeah, you can simply say this is our double, it means wrapper class at line number 7, and we are converting at line number 9 into primitive type. Once you are trying converting wrapper class into primitive type, that's called unboxing. See on screen. It will give us the output what we are expecting. See. Then in this session, we learn here the first concept is JVM architecture. JVM, it means Java Virtual Machine. There is one more concepts available like JDK, JRE, and JVM. See, JDK, it means Java Development Kit. Java Development Kit. JRE, it means Java Runtime Environment. And the next one is JVM. See, Java Development Kit, it means whenever you are going to install the Java, like Java 17, Java 8, whatever Java version you are going to install, it means you are installing the JDK actually. And JDK itself available JRE, and JRE itself available JVM. Then without JDK, you are not able to edit your Java application in Eclipse or otherwise IntelliJ. It means you must need to install the JDK before going ahead with the create the Java application, because JDK, it will help us to develop the Java application, right? Yes. And JRE, it means Java Runtime Environment. Without JRE, we are not able to run the Java application. It will help us to run our Java application. And JVM, it means Java Virtual Machine. Once you compile the program, like it converted dot Java, it means source code file into dot class file. The JVM have input as a dot class file, and then accordingly it will go ahead with the split into those memories. Then JVM, we have available here class loader. It will help us to load the dot class file, and once it load the dot class file, then accordingly here we have available JVM memory, and it will split into particular area. Then first we have available method area. Method area, it means whatever class level information you can simply say, like instance variable, static variable, method, static method, right? Those always will be class level. Such information always goes to method area. Heap area, it means you can simply say whenever we are going to create the object, it will goes inside heap area. And JVM language stack, it means whenever you are creating any like local variable, such type of data, right? It will goes to JVM language stack. And PC registers, current execution instruction, it will goes inside PC registers. Native method stack, it means you can simply say these are the legacy methods. And next we have available execution engine, that's called Java interpreter, itself available JIT compiler. And JIT compiler, it means just in time compiler. It will help us to improve the efficiency of our Java application. And next we have native method interface, native method libraries, those are the legacy things. Then JDK itself available JRE, and JRE itself available JVM. Like this is high level like overview of JVM we have taken here. Coming to next is we learn here concept like typecasting. Typecasting, it means convert one type into another type. There are two types of typecasting available in Java: upcasting and downcasting. Upcasting, it means lower to higher. Best example here into double. One more example I am giving here. You can simply say long to float as well. Even long to double also, this is the best example of upcasting. It means lower to higher. Best example into double here. And downcasting, it means higher to lower. See, here double is higher, int is lower. Double to int. This is the best example of, you can simply say, downcasting. Then coming to next is autoboxing in Java. Autoboxing, it means convert primitive type into wrapper class. Here is the best example. Int is a primitive type. We have converted into wrapper class as a integer. Then wrapper class first letter must be capital. Then one more example here, double to double. This double is a primitive type and we have converted into wrapper class. Next is unboxing in Java. This is exact vice versa about our autoboxing. It means convert wrapper class into primitive type. See here, integer is a wrapper class and the primitive type is int. Again same boolean to boolean, character to char. It means converting wrapper class into primitive type. That's called unboxing. Now we'll come up with your questions. If you have any questions, then feel free to ask your questions on those basic concept. I hope practically it's very easy, but till if you have any questions and the real-time usage of those typecasting example, I will give the best example here. Whenever you are getting the data from user interface, this data always comes as a string format. Then we need to convert into particular type. Suppose contact number data coming from user interface as a string, we need to convert into long. Salary coming as a string, we need to convert into particular format as double. Same for date and many more example available there. Fine. Then advanced session, you will get the more clarity how like we are going to do the typecasting. But today's session, we have just gone through the basics. Okay. What is typecasting? There are two types of typecasting. And then what is autoboxing and what is unboxing here. But till if you have any questions, then feel free to ask your questions.